And this question it is given that a slab of stone of area 0.36 meter square and thickness 0.1 meter is exposed on a lower surface to steam at 100 °C. So we can say that we are having a conductor over here, and one end of this one is maintained at a temperature of 100, and a block of ice at 0 °C is rest on the upper surface. So on the upper surface we can take it as it is nothing but ice at 0 °C. The in a 1 hour 4.8 kilogram of ice is melted. So we can take it as there will be a flow of heat energy from high temperature region to low temperature region. Because of that, in a time of 1 hour, when time is equal to nothing but 1 hour, the 4.8 kilogram of ice is melted. So mass of ice converted into water, we can take it as 4.8 kilogram. The thermal conductivity of slab is given as the thermal conductivity of slab is Rm is to find out what about the value of K. A latent heat of fusion of ice, which is given as nothing but 3.36 into 10 raised to 5 joules per kilogram. So you can write over here the rate of flow of heat energy dq divided by dt is equal to Ka delta T divided by L, which is equal to, we can write for a long time, we can take it as Q divided by T, and this Q is utilized for melting ice, so Q we can take it as M into latent heat of fusion divided by time T. So we can write this Ka delta T divided by L is equal to Q by T, which is equal to M into latent heat of fusion of ice divided by time. And in this question, Rm is to find out the value of K, so we can write M into latent heat of fusion into length divided by A delta T and T. Now we can substitute this value. The mass of ice melt is given as nothing but 4.8 kilogram. Latent heat of fusion of ice is given as 3.36 into 10 raised to 5. The length of this material in this question, it is given that its length is 0.1 meter, so we can write 0.1 divided by the area of cross section. And this question, it is given that 0.36, so we can write this as 0.36 into delta T, which is 100 and 0 on other end, so difference in temperature is 100, and T we can take it as nothing but time, which is given as basically 1 hour. 1 hour we need to write in SI system, so we need to convert it into seconds. 1 hour is 60 minutes and 60 seconds. So we can find out the value of conductivity K, which is 1.2444.